This video is going to focus on 3 problems on how to use fundamental identities and appropriate operations in order to simplify given trig expressions here. So rule of thumb before jumping into any of these style of problems, different things that might help. If you're given anything that's not a sine and a cosine, a lot of times you might want to take a look at some identities and see about how you convert those to sines and cosines. Sometimes take a look at the calculations that you have going on. For example, we have multiplication here. Sometimes it's better to keep it factored. Sometimes it's better to go ahead and multiply it, really just depending on the problem. Also, you want to think about different factoring techniques and things like that that you might be able to do in order to simplify whatever given problem they have for you. So first thing that I actually want to do with this problem here is I see that I have a tangent x here and I have a cotangent x there. I want to go ahead and do some substitutions for this here. So the identity I'm going to be using first is that tangent x is equal to sine x over cosine x. So I'm going to go ahead and plug in sine x over cosine x here. And then cotangent is just the inverse of that. Cotangent is equal to cosine x over sine x. So I'm going to go ahead and do those substitutions in there in order to get rid of our tangent and cotangent, change those to sines and cosines. The next thing I'm going to do after this is actually multiply this out. I have the sine x cosine x over here. We're going to distribute this to inside of our parentheses. First things first, sine x cosine x times our numerator. Again, because this is a fraction, again, we're doing fraction multiplication. Numerator times numerator, denominator times denominator. The 1 times the cosine in the denominator is going to just be our cosine. When we multiply our numerator, sine x times sine x is sine squared x, and then just drop down the cosine along with it, right? Sine squared x cosine. Plus, drop down your plus sign here, and our second multiplication, sine x, we're going to drop that one down, and then we have a cosine times a cosine to make a cosine squared x, and that is going to go over our 1 times sine x, which is sine x. Now after this, taking a look at our problem to see what possibly we can do a little bit of simplifying here. I see that I have a cosine in my numerator, a cosine in my denominator. Those we can cancel out. Cosine cancels with cosine. And if we take a look at this fraction over here, we actually have a sine that can cancel with the sine. Alright, so after we cancel that, let's see what we're left with. We have a sine squared x here left for our first fraction, plus our cosine squared x right over here. And this works out perfectly for us because there is an identity that says that sine squared x plus cosine squared x, this is all equal to a 1. Our next example here, secant x plus tangent x times secant x minus tangent x. So taking a look at this problem, I don't know about you, but one of the first things that I'm noticing here, notice we have a secant x in the first position, tangent x in the second. One is a plus, one is a minus. So the way that this is set up, this is following in line perfectly with the difference of squares. But if you do not see that, since this is set up as 2 polynomials here getting multiplied together, let's go ahead and multiply this out and see what happens. So taking secant x times secant x is secant squared x. Drop down our minus sign. Secant times tangent is just secant times tangent. Distribute your tangent, and then we're going to get a positive tangent x times secant x. And then we're going to have here minus a tangent x times tangent x is tangent squared x. Notice our 2 middle terms here are going to cancel. A negative secant tangent x plus a secant tangent x are going to cancel out with each other, letting us drop down this secant squared x here in front, minus this tangent squared x back here that we have. Taking a look at what we have left over here, secant squared x minus tangent squared x. This actually follows perfectly along with one of our other identities here. We have an identity that says 1 plus tangent squared x is equal to secant squared x. But if we just take this here and we subtract tangent squared x on each side, that will leave me with 1 is equal to, well, secant squared x minus tangent squared x, which is exactly what I have right over here. So that means secant squared x minus tangent squared x is equal to a 1. Our next example here, secant squared x minus 4 over secant x minus 2. So, in taking a look at this problem, and again, keep it in mind, these types of problems are extremely important to trig and pre-cal, because there's a lot of times we're trying to solve an equation or we're trying to do something, and we have to use our identities to get it to simplify it or make it convert to something else in order to make it easier to work with. So we are going to need to get familiar with being able to take a look at these problems and try and figure out what can we do to these, how can we simplify them out. Taking a look at this particular example here, the first thing that I notice, especially that numerator is set up perfectly using the difference of squares factoring technique. If you take a look, each one of these terms are perfect squares. Secant x times secant x to get that first term, 2 times 2 to get that second term. So again, our difference of squares factoring technique says if you have a squared minus b squared, that is going to factor to a plus b, a minus b. Where our a here is going to be secant x for the first part, and for b it's going to be a 2, right? Secant times secant, 2 times 2. So that means that numerator is going to factor to secant x plus 2, secant x minus 2. Our denominator, we're just going to move our denominator right on over secant x minus 2, which is perfectly fine, because now that we've factored the numerator, we should see that we have a secant x minus 2 in the numerator, secant x minus 2 in the denominator. Those could cancel out, leaving us with a secant x plus 2, which is our final answer here.